Hello everyone, welcome back to the training. I hope I'm clearly audible to all of you. We'll start in a few minutes, and today we are going to speak about some amazing protocols and would be looking at configurations of them on the Cisco Packet Tracer. Let's wait for a few more minutes and then we will begin. All right. So welcome back, everyone. Welcome back to the CCNA training. I hope you all are doing well. And in the previous session, we spoke about things related to the networking models. We looked into TCP/IP, we looked into OSI model, and also observed the working of an amazing protocol called ARP, and looked at some basic example of how ARP works in a great simulated tool called Cisco Packet Tracer. I'm hoping that you all must have downloaded and installed Cisco Packet Tracer. So let's get started. Today we have got some amazing technologies and protocols to discuss. Let's see how these things work and understand them one by one. The very first thing that we are going to look at is how a LAN works. I'm sharing my screen. And my screen must be visible now. Perfect. Cool. So in the previous session, what we tried was we looked at a simple topology where there was a PCA connected to another PC, PCB, and we configured them on the same network and looked at how the ARP process works. Let me know in the chat, what does ARP stands for? Perfect. ARP stands for Address Resolution Protocol. We connected simply two devices together, so we didn't require the device called switch. But now today what we are going to look at is how we can connect multiple devices together. To connect multiple devices together, I need this device called switch, right? And switch will help me to forward the traffic between these devices. When we speak about switches, we call them smart devices. And to understand why these are smart devices, we need to learn about something called as hub. So back in time, when the network was there, we used to connect multiple devices together using this device called hub. Now hub is called as a dumb device and switch is called as the smart device. Let's understand why. Let's try understanding how hub operates, and then I'll tell you the difference between hub and the switch. So when I talk about a hub is a dumb device. Why do we call it a dumb device? Let's understand. Let's assume there are four PCs connected to hub: PCA, PCB, PCC, and PCD, right? And my hub is basically used for letting my devices communicate to each other. But in the case of hub, there is a problem. The problem is that hub only broadcasts. When we talk about hubs only broadcast traffic. What does that mean? That means that if PCA wants to speak to, let's say, PCB, so the packet first will go from A to hub, and hub is simply going to broadcast it, will send it to all the connected devices except the port where it received the packet from. Make sense? So even if PCA just wanted to deliver the packet to PCB, hub is going to send it to D and C as well because it only broadcasts traffic. Do you think it is suitable for a big network? No, right? It's going to lead us to bandwidth wastage. It's going to lead us to unnecessary packet receivers where my PCC and PCD, even when they don't want that packet, they'll still have to receive it and then deny that packet by looking at the destination IP, right? So all those problems are going to be there. Secondly, hub operates with half duplex only. That means at a time, only one device can communicate in a segment. Okay. So for example, if in this topology, PCA is sending some traffic to hub, then at that time, no other device can send or receive traffic. Clear? So when we talk about the network segment and we talk about the legacy devices like hub don't let devices operate on full duplex. It only operates on half duplex, meaning at a given point of time, only one device can communicate in the given network segment. Clear, guys? Then in the case of hub, there is only one collision domain. The whole thing is your collision domain. What is a collision domain? A collision domain is the segment where if two devices are communicating at the same given time, then the collision might happen. Okay. Frames may collide with each other if they are communicating at the same point of time. So hub operates with only one collision domain. That again brings us to same thing that at a given point of time, only one PC is allowed to communicate with the hub. If any other PC will also try to communicate, there are possibilities that the frames might collide with each other. So in a collision domain, only one device is able to transmit at a given point of time, while the other devices will have to wait before the transmission is completed to avoid the collisions. Clear, guys? Then we switched on to smarter devices, switches. Now, switches are called smarter devices. Why? Because first of all, they can do unicast, they can multicast, and can broadcast traffic. Switches have the ability of operating at full duplex. That means at a point of time, the devices can transmit and receive traffic at the same point of given time. So they operate at full duplex. And collision domains are going to be equals to the number of ports. What does that mean? That every port is going to maintain a separate collision domain. So there is no possibility that if PCA is sending some traffic, then PCB or PCC cannot send or transmit traffic. They all have separate collision domain. They have collision domain on the basis of per port. So that's why we can say there will be no problems of frame colliding with each other if some device is already talking in the given segment. Clear, guys? One more difference that I can tell you about is that hub operates at layer 1. It's a layer 1 device. Whereas when we speak about switches, switches are layer 2 devices. Switches maintain MAC table or forwarding, which is the main thing why switches are called smarter devices. Let's understand how this works. What happens when you communicate through a switch? Assume that you have a switch and your switch is connected to PCA, PCB, PCC, and D. Like I said, switch has its own memory inside which it maintains a MAC address table. In the MAC address table, it fills the information about the ports and the MAC addresses which are connected on those ports. Assume that PCA is connected on 0/1, PCB is connected on 0/2, C is connected on 0/3, and this one is connected on 0/4. Okay. Now, when PCA will generate some traffic, let's say for PCB, it's going to be received by my switch on which interface, guys? 0/1, right? So on 0/1, I will save the MAC address of PCA. Assume that it is AA. Okay. Now the packet was generated for PCB, right? So the packet will have the information about source IP, destination IP, source MAC, and destination MAC is something that we have to learn. What protocol do we use for learning destination MAC? ARP. Perfect. So an ARP request will be sent by PCA to the switch, and ARP request is forwarded as a broadcast, right? So switch will give it out on PCD, PCC, PCB, asking all of them that who is PCB. To which my PCB is going to reply back with an ARP reply. So switch will learn now the MAC address of PCB through the ARP reply and will save it in its MAC address table. Okay. After that, that packet would also be, I mean, the information about the ARP would be provided to PCA also. Then my transmission will happen from PCA to PCB. Similarly, through this process only, gradually it's going to learn about the other MAC addresses also and will fill up the MAC address table. So that the next time when my PCA wants to send something, let's say to PCC, my switch will directly look into the MAC address table, will find out if PCC or the MAC address CC is connected to it. It will know it is connected to it on 0/3. So switch is going to forward the traffic on 0/3, making PCC receive that particular traffic. This is how a switch learns about the MAC address tables. I mean the MAC addresses of the connected devices. And we call this process as unknown unicast flooding. Let me know if there is any doubts or queries. Okay, so we have a question. What if admin changes the ports? So if admin will change the port, the MAC address will be learned on a new interface, right? So the information will be updated inside the MAC address table. Anuj, I'll show you now the working of unknown unicast flooding on packet tracer. So I'm sharing my screen. I'm sharing my packet tracer window and it should be visible now. So like we have discussed, I'll take one switch and I will connect 4 devices to it. PC A, B, C, and D. To make them communicate, first of all, I'll go into connections and connect the cables between my switch and PCs like this. Okay. And like I have told you earlier also, when you want multiple devices or multiple connections, you can select the option with a control while pressing the control key. So when you do so, it lets you connect multiple cables and put multiple devices. Now, after this, to make all these devices communicate with each other, I have to put them in same network, correct? So I will configure them under the network 192.168.1.0/24. Let's do that. I'll go to PC0 desktop IP 192.168.1.1. 192.168.1.2, 192.168.1.3, and 192.168.1.4. Then I'm going to switch to simulation mode and will try to make my PC0 speak to, let's say, PC2. Now you have to just observe the whole thing that I have explained. There are two packets. One is ICMP packet. Like I've told, this is your ping packet. And one is ARP packet, which is used for learning the MAC address, correct? My ARP packet will go from PC0 to switch, and it will be broadcasted to everyone. As we can see, it got received by PC1, PC2, PC3, correct? Now, because my communication was initiated from PC0 to PC2, the ARP request is going to be denied by PC1 and PC3. Make sense? But who will give me a reply? PC2 will give me a reply with its MAC address. So if I say next, I'll receive a reply from PC2. Now my switch is going to add the entry about the MAC address of PC2 in its MAC table. It will learn it that on FA0/3, I have MAC address of PC2. Okay. Then it will be forwarded to PC0. After that, my ping packet will come forward. My ICMP or ping packet will move from PC0 to switch to PC2, and I'll get the reply directly. The communication will directly happen now between PC0 and PC2. This whole process is called unknown unicast flooding. Clear? So that's how this works. Let me know if there is any questions or doubts. Anytime if the MAC address is updated, the table will get updated with the new information when a new packet will be received. So assume that earlier my MAC was AA, but my switch learned that on FA0/1, the MAC address which is connected is AA. Okay. Now in future, let's say I replaced this PC with a different PC, and now my MAC address got changed to, let's say, double P. So the moment this new PC having MAC address double P will send some traffic to switch, my switch will update the table and will change the information for port FA0/1 from the MAC address double A to the MAC address double P. Make sense? How the switch recognizes where is PC2? Is it by the host name, as MAC address hasn't been learned unless response is received? Exactly, Sayed, because we don't know where is PC2, that's why we are broadcasting. So we give it to PC1, PC2, PC3, all of them. But the moment I receive a reply from PC2, I realize that, okay, this is the device I was trying to look forward to. Afterwards, when PC0 will send any packet, let's say for PC2, I know it exists on FA0/3. So I'll directly give it out on FA0/3. Varun, because the first packet was ARP packet, it was supposed to be broadcasted. After the process, when I have learned the destination MAC address, my communication will happen in a unicast manner directly from PC0 to PC2 because I have learned the MAC address, right? So is it by host name identification initially, then MAC address is propagated to build up the once the host name matches? It's not the host name, Sayed. Like I have been saying earlier also, we don't know how many devices are there. I mean, we don't know exactly where is PC2, right? PC2, we are able to use the name because we see that name here. Switches don't care what the device is called or what is the name of the device, right? They will simply broadcast it to everyone, and the device replying back to that broadcast message will be memorized with its MAC address in the MAC address table. Tushar, this is what we are discussing here only. Like the ARP is this process only, where a message is generated to learn the destination MAC address, and then we receive a reply to it, which is called ARP reply. We discussed this in the previous session also. We have another question. Will the first message drop? There is a high possibility that your first packet will drop because ARP will take a little time to learn the destination MAC address. So for example, if I go to PC0 and I see command prompt and try to ping, let's say PC1, which is there with the IP 192.168.1.2. I receive all my replies. After the communication has happened, I can say my switch must have learned about MAC address of PC0, PC1, and PC2, right? Let's try to see. We have this option of inspect. I'll click on my switch. I'll check MAC table. Do you see that? We have successfully learned three MAC addresses, one on FA0/1, one on FA0/2, one on FA0/3. Because the communication so far has only happened between PC0, PC1, and PC2. The moment I make some communication with PC3 as well, let's say I'll try to ping 1.4 also, which is my PC3. After that, if I recheck my MAC address table on switch, we can see the information of FA0/4 is also now updated. So it has learned the MAC address of all the connected devices successfully. I'll also show you how you can check the MAC address table in the CLI as well. So let's have a look on that and let's try understanding how CLI works. Now to interact with the network devices, there is this feature available or the protocol available called CLI. CLI stands for Command Line Interface. Okay. So when you talk about production environments, you connect to the devices through console cable. What you do is you take your laptop near to the network device. Then you take the console cable. Here I have this option as the console cable. You take the console cable, connect the cable in RS-232 port of the laptop and connect it on the console port of the switch. Then you open your laptop and you open some terminal application. You all must have heard about the application Putty. Putty is one of the terminal applications. So you use such terminal applications to take the CLI access. Here in Packet Tracer also we are provided with this terminal application. So I'll click on that. These are some details that you have to set. It's already pre-configured here and I'll just say OK. The moment I say OK, I get the CLI access of my switch. From this particular CLI access, I can monitor or manage my switch. I can even configure new things on it. Okay. We are using it in Packet Tracer. So we also have an alternative. Let's say if you don't want to try this console thing, you can just click on your switch and a window opens up, right? In this window directly, you can see you have got the CLI tab where you can access the CLI of the device. But very obviously, this is possible in Packet Tracer only. In real life, we make connections using console cables. Okay. So this is also pretty important to understand and learn. And I'll give you a few minutes, let's say 10 minutes, to figure out this. Create a small LAN network like I have shown you here. Take a switch, connect 4 devices to it, put them in same network. Then connect a laptop using console cable, and inside the terminal application, try to take the access of the CLI. If you see something written on a black screen looking like this, that means you are inside CLI. Now, how to use CLI? What are the different modes of CLI? I will talk about that in a minute. Take the time, try this quickly, and then we shall continue. Okay, those who don't know how to download Packet Tracer or wants the downloading link or something, what you can do is on your browser, you can search for Cisco Packet Tracer PyNet Labs, and you will find a blog that explains what is Packet Tracer, how to use it. So you can check it from here and can download it in your devices. Okay, I'm hoping that by now everyone must have experimented with a small LAN network in their Cisco Packet Tracer labs. Now let's see what all are the switch components. Inside a switch, there are four major things. That how can we resize the Packet Tracer entire screen? Okay, there are a few customizations that you can do from options, preferences. When you go into preferences, and if you, let's say, want to see the port labels like FA01, FA02, like you can see on my screen, for that, you have to check this box, always show port labels in logical workspace. If you uncheck this, the port labels are gone. If you check it, they'll appear. Okay. Second thing, how to change the size. You can go into font. Inside font, you can change the application size. If you increase it, let's say, and apply, you see everything gets bigger. If you decrease and then say apply, so yeah, you can set the size as per your preferences. There are other options also to change the color schemes and stuff. You can definitely experiment with that as well to make it more as per your preference. Now, this is my topology where a switch is there connecting all these four devices, right? So I was talking about the components of my switch. Inside a switch, there are four things. First thing that is there is NVRAM. Second is RAM. Third is ROM. And fourth is flash memory. Just like in your laptop, there is a RAM, there is hard drives, there is either, you know, a hard drive, or you sometimes might have heard of SDDs, right? SSDs. So these are some memories that your device requires for processing. Similarly, a network device also requires different types of memories for processing various things. NVRAM stands for non-volatile RAM. It's a permanent storage. And what do we store inside it? We store startup config. Now, what is startup configuration? I'll let you know later on. Inside the RAM, which is a temporary memory, we store running configurations. Again, this is something I'll explain you about later on. Then ROM contains bootstrap code, basically the code for starting the device. Okay. And after that, flash memory contains Cisco iOS software, the operating system of the device. This is how the four different types of memories are used inside a switch. Now, how do we manage these configurations, or how do we manage or monitor whatever is running on my switch? We do it through CLI. And like I told you, CLI stands for what? Command line interface. So when you will take the access of CLI, you can click on it and you can hit the enter button. So when you will do so, you will find a prompt like this, where there is switch written and there is an angular bracket. This prompt represents a CLI mode, which is basically called as user mode. In the user mode, you get very limited access and can run very few commands. Very few basic commands can be executed in the user mode. So we escalate our access or escalate our permissions by entering into the next mode, which is called as privilege mode or the enable mode. For entering into the enable mode, there is a command called enable. You just have to type down enable and you get inside enable mode. This second prompt of mine is enable mode. And enable mode gives you the access of running all show commands or monitoring protocols. So when you are inside the enable mode, you can run show commands. There are different show commands for checking different details. For example, if I want to check how many interfaces of my switch are there and the state of those interfaces, whether they are up or not, I can check that by saying show IP interface brief. Okay, you have to type the command simply and hit the enter button to get the results. So you can see a long list is created. These are all the interfaces that I have on my switch. And out of them, how many are up? FA01, FA02, FA03, and 4. These are up. See, because these are the devices. These all 4 devices are connected to these 4 interfaces. Then there are also FA05, 6, 7, and so on till the end. But they all are down because we are not using them yet. This is how show commands can help you in monitoring what's going on the device. Another show command that we are going to learn is for checking the MAC address table. So I'll hit the enter button again, and here I'll type down show MAC address hyphen table. Now you see, I didn't type it completely, it automatically got completed. But how does that happen? Let's understand. CLI gives you the ability of not just using short forms, but also auto completing your command by using the tab button. For example, if I say show MAC space ADD and hit the enter button, then also it brings out me the results, right? It brings out the MAC address table, but that's not the complete command. The complete command is actually show MAC address hyphen table. This is the complete command. But the good news here is that you don't have to type it completely every time. You can use the tab button to auto complete the command. For example, show Mac ADD and I will press the tab button. The moment I press the tab button in the next line, we can see my command gets auto completed. And if I hit the enter button, I can see the MAC address table. Currently, my MAC address table is empty. But wait a minute. We earlier have made PC0, PC1, PC2, PC3, all of them, we have made them communicate and my MAC addresses were also learned. So where did they go? Basically, if your MAC address is inactive, which is basically there is no packet being sent or received from or through that particular MAC address, then after 300 seconds, my switch is going to remove it from the MAC address table. Here, so there is an aging time on switches, which is 300 seconds. That means 5 minutes. So basically, if there is a MAC address which has been inactive for 5 minutes, we will remove it out of our MAC address table. Clear, guys? We do not need any IP on switch. We can ping devices directly by connecting it to a switch. Switch is not going to check the IP information as it is a layer 2 device. All it checks is the MAC address information, for which you do not need any additional configuration. So you simply connect your devices and you are good to go. Saurabh, make sure you are putting them in the same network, otherwise they'll not communicate. Exactly, Nicholas. If there is some inactivity and the MAC address is not being used, my switch will wait for 300 seconds. After that, it will remove the MAC address from the MAC address table. So that means if I reinitiate some communication from, let's say, PC0 to PC1 and PC0 to PC2, then PC0 to PC3, and go back to my switch and try to run the same command again, show MAC address table, then this time I can see the results that FA01, FA02, all of them have learned the MAC addresses on the device. Sanju, yes, we do not need any additional configuration for just simply letting PCs communicate to each other. There are some more protocols, like we will be speaking about VLANs later on, which will require some configuration on switch. As of now, we do not need any configuration, and this is how exactly it works in real life also. So yeah, we have explored the enable mode. We run show commands here. I showed you some examples as well. Show MAC address table and show IP interface brief. Like I said, you need not to type the complete commands. You can use short forms also. If I say show IP int BR, this is also going to help me get the results. And anytime you have a question, you are not sure what should be the next word, you can use question marks also. So if I am saying show IP interface, I can recall up to this level, but I'm not sure what is the next word. I can press the question mark and it will tell me what all possible values can be there. So you can check VLANs, you can check brief. So we wish to use brief. So I'll type BR. I'll press the tab button. It will auto complete the command. I can hit the enter button and I'll get the results. That's how the enable mode works. Now, whenever you want to configure something, you need to get into global configuration mode. For getting into global configuration mode, you have to type down the command configure terminal. And this takes you to global configuration mode. Here you can make configurations. You can make changes on the device. So from the user mode, if you wish to switch to the enable mode, you have to type the command enable. From the enable mode, if you wish to switch to the configuration mode, you have to type the command configure terminal. And the final mode is my configuration mode. I'll type down that this is global configuration mode used for making configurations. Are we clear so far, guys? Give me a thumbs up if we all are good with whatever we have discussed so far. Saurabh, you cannot ping them from switches. switch will need an IP address for that. You can only ping from one PC to another PC. From your switch, you will not be able to ping. Switch will need IP for that. We haven't configured it. So that's why your ping is failing from switch. All right. Now, let's say from global configuration mode, I want to get back to my enable mode. So what I need to do is I need to type the command exit. If you type exit, it will take you back to the privilege mode. Here again, if I type exit, it will take me back to the user mode. So exit is the command to get back into the previous mode. Clear, guys? These are the different CLI modes that a network engineer has to work with. So try to check them on your created topology. Take the access of CLI, type down enable configure terminal and see, observe how the modes are changing. Also use the command show MAC address table to check the MAC address table of your switch. So first you will take the access of the CLI, type enable, then type show MAC address hyphen table to check the MAC address table. Then you can type configure terminal to get into the global configuration mode, and then you can use exit to get back to the previous mode. Try these commands on your switch and see how things are working. How to see the packet flow? Mudassar, that was just done for making you guys understand. You don't need to do it. You can directly just look at the real time working. But if you click on this simulation mode here on the bottom right side, it will show you the packet flow. But I do not suggest you. If you are just testing and configuring things, then I recommend you to just work in the real time mode. Try out the different CLI modes, and then we are going to learn some amazing protocols. If you guys are facing some issues, you can try explaining the problem in the chat so that I can explain. Okay, how you can assign IP to the end nodes? You have to click on PC, a Windows open up, and you have to click on IP configuration, type the IP here, type the subnet mask here, and you are done. No, we do not need to provide any IP on switch. We just need to put it on PCs to make PCs communicate with each other. To access the CLI, first you can just simply click on the switch and click on the CLI tab, or otherwise you can connect a laptop using a console cable. Then on your laptop, go to the desktop, click on terminal and say OK. Here you will get the CLI access. See the same CLI access, which basically we have observed onto the switch as well. So this is another way of accessing the CLI. You don't need any IP on laptop if you are using a console cable. And if you are using laptop here to connect with the switches, then in the exact same manner, you can assign IP like this. On the laptop also, you'll see a desktop tab. Go to IP configuration and put IP address on it. Guys, seems like we are not practicing at home after the sessions. In the previous session, we have discussed how to assign IPs, and I gave you even a blog link as well to try out IP configuration with a simple small topology. So do practice at home also, like after your session is done, do practice, take out some time to revise the concepts. Only then you will be able to catch up with the training discussions, right? So you have to dedicate some time if you are really willing to learn networking. To connect the console cable on laptop, you have to use RS-232 port. On the switch, you have to use console port. Go to your laptop and you need to click on terminal application, then say OK, you will get the CLI access of the device. Or otherwise, like I said, simply click on the switch and take the CLI access through the CLI tab. Clear, Saurabh? Perfect. So we have a question, why are we not using simple cable uh, between the laptop and switch? So basically, these are connected to communicate with each other, right? But this one is connected to take the excess of the switch. So for this, we need a special type of connectivity called console cable. Console cable gives us the ability of taking excess of the network devices on the end devices like this laptop, right? So when you are a network engineer, you will receive a switch. You have to configure it or manage it. How will you access it? In our packet tracer, we have the option of clicking on it and then taking CLI access. But in real life, we cannot click on that actual hardware device, right? So we take our laptops, we go to the switch, we put the console cable in the switch, we put the console cable's other end on the laptop and open applications, terminal applications, like I mentioned earlier, also putty to take the CLI access of that particular network device. Make sense? But when we are talking about these devices, these can be simply assumed that, let's assume this is your sales team. Now they don't want to access your switch, right? They simply want to communicate with the other connected devices. So for them, I need a simple connection like this one. I don't need a console cable for these devices. Make sense? Saurabh, make some communication between your end devices and then your MAC address table will show the MAC addresses of connected devices. Console cable is neither straight through nor crossover. It's a different cable specifically created for devices to take the excess of CLI. It's not used for sending the data traffic like the crossover or the straight through cable. So Sayed, when you are in the enable mode from the console connected end devices, you are actually using the switch CLI, right? From the switch, as I have mentioned earlier, you cannot ping the connected end devices. So to check the reachability, you have to go to either one of this option, this utility which is there, which can help you send traffic from PC0 to PC1 like this. And you can see the results of that here on the bottom right side, which is successful. Or otherwise, like I showed, you can go to command prompt and type down ping and then the IP of the destination PC 192.168.1.2. So if you are getting your replies, that means the reachability is there. Make sense here? No, ping is not layer 2 process, it's a layer 3 process. So it operates on the network layer, not the data link layer. As it's using IP addresses, so we can understand that layer 3 connectivity is something which is required. Okay, I think we are good to move ahead. By now, you guys must have tested these different CLI modes. Now it's time to add a few more bunch of devices in the topology. To make it look nice, I'll just clear it a little bit and I'll also put a screenshot of this in the Telegram group so that you guys can use it later for the reference. Now what I'm going to do is I will add another switch into my scenario. I'll just delete this console connected laptop. And I will just put it here on the left side and move my devices a little to the bottom side. Like this. Okay. Now I am going to add another switch into this situation, a switch number 2, which will connect another set of devices, PC4, PC5, PC6, and PC7. So let's connect them all with my switch. And this time, the network that I will use is going to be 192.168.2.0/24. Okay. So let's begin putting the IP configurations. I will go to my PC4 desktop IP. And here I will write down the IP 192.168.2.1. Subnet mask, the default subnet mask appears automatically. So I'll just keep it like that and close it. PC5 desktop IP 192.168.2.2. There you go. PC6 desktop IP 192.168.2.3. Then finally 192.168.2.4. Now, if I make PC4 communicate to PC5, 6, or 7, will that bring me reply? Or would that work? What do you think? Yes or no? If I ping from PC4 to PC5, 6, 7, will I get a reply? Yes, because simply we can say they all are part of same network, right? Now what I'm going to do is I will connect my switch 1 with switch 2. Now, what do you think? If I make PC0 send a ping to PC4, will I get a reply? Most of you are saying no, right? And yeah, exactly. The reason behind that is because they both belong to different networks, correct? PC0 belongs to the network 192.168.1.0, having the IP 192.168.1.1. And PC4 is 192.168.2.0, having IP 192.168.2.1. In such a situation, when I have got two different networks, which device can help me connect them together? We need a router. Amazing. So what I will do is I will delete this connection between my switches and I will go to network devices and I will place a router, the last router from the options. Okay. Observe this very clearly. I don't want you to make mistakes. From the available options, you have to pick up the last one, as that's a normal, simple, basic router that we are going to start with. So I'll pick up the last router, I'll put it like this, and I will connect my cable from switch 1 to the router and switch 2 to the router. After this, we can see that the router link are red. That means they are down. The link between the router and the switch are down. They are red. So we need to configure the router with some configurations to first of all bring this link up. And then I will also have to configure some IP address on the router so that these devices can use that IP as its default gateway. What is default gateway now? I am sitting in my house. If I have to go outside, I have to go out through my main gate, correct? Similarly, if my friend has to enter into my house, they will come inside through the main gate, right? Similarly, from this network, if I want to go outside into a different network, I have to cross the gate. That's why we call this router gateway, default gateway. Router will let me send traffic from my first network to the second network. Now, how this configuration works, let's have a look. I'll go to my router. I'll go to the CLI. Here, the very first thing you will find is a question. Would you like to enter the initial configuration dialog? Yes or no? I am going to say no. Enter. Then it says press return to get started, which is the enter button. I'll hit the enter button. And on which mode are we landing, guys? Which mode of the router is it? Like we discussed, this prompt, this angular bracket represents user mode. So we are in the user mode. How to enter in the privilege mode or the enable mode? Using the command enable, correct? So if I type enable and I hit the enter button, I get the access of privilege mode. Then here I can run show commands. But my task this time is not to check any MAC address table or the IP details of my interfaces. My task is to configure the interface FA0/0 and FA0/1 to bring them up or to make my first network connected to the second network. For which I need to make some configurational changes, for which I need to get into global configuration mode. To get into the global configuration mode, I again have to use a command, which is configure terminal. So I will click on my CLI and type configure terminal. And we are in the global configuration mode. Here I am going to use another command called host name for changing the name of my router. So currently the host name is router. I will change it to, let's say, R1. Host name space R1, enter, and you can see the name got changed. Clear? Then I have to put IP configurations on interface FA0/0. So I will type down the command interface FA0/0 to get in the interface configuration mode. Now you see my prompt again got changed from config to config-f. Config-f represents interface configuration mode. Now, whatever commands you will type in the interface configuration mode will only get implemented on the selected interface. For example, I wish to put an IP address on this particular interface. So I will use the command IP space address, and then I can specify the IP that I wish to use. Let's say I will use 1.100. So I'll put the IP space, and then I have to put the subnet mask. So I'll put 255.255.255.0. That's the subnet mask which we use for /24 network, correct? So I can enter this command and then use another command, no shutdown, to bring my interface up. See, the moment I typed no shutdown and I hit the enter button, it says interface FA00 change state to up. And you can also see the red light got changed into green, correct? So now I have successfully assigned IP address on my interface FA0/0, as well as I have brought the interface up by running the command no shutdown. Any questions? Awesome. If I hit the enter button, I am still inside the interface configuration mode. I am done with the configs of FA00. Now I want to configure FA0/1. So how do I come back to global config mode? What command should I type? Exit, right? So I'll type exit. I'm back in the global config mode. Now I will select my second interface, interface FA0/1. Here also I will put the IP address. So on this interface, I need to use IP address from the network 192.168.2.0, correct? As the FA0/1 interface is connecting to 192.168.2.0 network. So here I will configure 192.168.2.100, 255.255.255.0, no shutdown to bring the interface up, and then exit. Any questions or doubts so far in understanding the configurations that we have done on the router? All clear? Perfect. I'm writing the commands here which you are supposed to run on the router. First enable, then configure terminal, then host name R1, then select the interface FA00, put the IP address on it, 192.168.1.100, 255.255.255.0. No shutdown, exit, then select the next interface FA0/1, IP address 192.168.2.100/24. No shutdown, exit. Now guys, obviously in your topology, the interface connections can be different. Possibly on the left side, you might have FA01 and on the right side, you might have FA00. So you have to be cautious at that time and make sure that you are using the correct interface and you are putting IP on the correct interface. Okay. Now we have configured my router's FA00 interface with the IP 192.168.1.100 and FA01 with the IP 192.168.2.100. These IP addresses are going to be used as the default gateway by these end devices. Okay, so far also we have not done with the configuration. So on this PC, when you configure IP, you see a field called IP address, you see a field called subnet mask, but then there is a field called default gateway. This is where I have to put gateway's IP. What is my gateway IP? for PC0? For PC0, PC1, PC2, and PC3, it will be 1.100. So I will put the IP 192.168.1.100 and then close this. Similarly, I'll go to PC1 IP. I'll change default gateway to 192.168.1.100. Then PC2 IP 192.168.1.100. PC3 IP configs 192.168.1.100. What will be the default gateway for PC4 now? Perfect. It's going to be 2.100 because these side devices are connected to FA01. So I'll go to IP configs and specify my gateway as 2.100. PC5 IP default gateway 192.168.2.100. PC6 IP default gateway 2.100. And finally, PC7 IP gateway 2.100. After all this configuration, if I go to PC0 and I try to ping, let's say 192.168.2.1, which is basically my PC4, then let's see if we get any reply or not. My first packet says request timed out. That means it got dropped. We didn't receive a reply for it. Can you guess why my first packet didn't get a reply and then later on I started receiving the replies? It's because of the ARP. Perfect. Because ARP is going to take some time to find out the destination MAC address. It's going to just, the timeout might expire for the first packet. So there is a possibility that when you send some traffic, your first packet or your second packet might drop. So you need not to worry if you are getting replies later on. Because once your device has learned about the MAC address, it will be able to get all the replies if you try to ping again. Now, when I ping 192.168.2.1 again, I do get all my replies. Similarly, if I ping, let's say 2.2, my first packet might drop, but after that, I'll start receiving replies. There you go. And congratulations, guys, you have learned how to connect to different networks through router. This is how routing is implemented. Let me know what questions or doubts you have got in this. Thank you, Sayed. I am glad you liked the explanations, and I'm hoping that everyone must have got it, how you connect two different networks together. Take your time quickly to test out the same. And like I said, be cautious while configuring your interfaces. There is a possibility that your left side interface might be FA01. So you do not have to just simply copy paste the configuration, but also have to make sure you are doing it correctly as per your topology. So take the time quickly, take up 10 to 15 minutes and quickly try out connecting two networks together. I'll be back in exactly 15 minutes. And by that, I am hoping that you all will be able to complete this lab. On PC2, if you check the default gateway, it is 1.100. So for all these devices, the default gateway is 1.100. For all these devices, the default gateway is 2.100. Yes, Abdul, like I said, please pick the last router. You must have taken up first router. Take the last router from the available options. DNS is not something we are going to talk about right now. We'll discuss that later. Awesome, guys. I can see your messages and I can see that most of you have completed it with a success. So, good job to all of you. And if you have got any questions, then you can post in the Telegram group. While connecting to router, getting error, cable cannot be connected to that port. Nancy, you have already utilized your ports. Okay. So for example, I have utilized both my ports. There are only two ports on 2811 router. Now, if I take another switch, for example, and try to connect my cable from switch to router, so I get the same error. The cable cannot be connected to that port. Why so? Because there were only two ports and I have utilized both of them. How to check if the configuration is right? Yeah, you can try to ping from one side, from one network to the other. If you get a reply, that means the two different networks are connected together. Or otherwise, the show command that I told you guys earlier, show IP interface brief, that can also be used here to check the IP configs. Like if I say enable and say show IP interface brief, I can see that on FA00, the IP assigned as 192.168.1.100, and on FA01, it is 192.168.2.100. And you are using 2811 router, Nancy? Then there is a possibility that your router must be off. Like from the physical tab, did you just click on the switch? Probably this switch button shuts down the router, and when the router is off, you cannot add the. But then also the cable should get connected. Are we good to proceed, guys? Yes, Sayed. Both the switches needs to be connected to the router. Okay, now we are going to talk about another protocol called DHCP. DHCP stands for Dynamic Host Configuration Protocol. Dynamic Host Configuration Protocol is used to assign IP addresses to end devices dynamically. For example, in our topology, we had switch and we had four end devices connected to it. On all the four end devices, I had to assign IP address one by one statically, correct? I had to connect to my first PC, take the access, get into IP configs, then type down the IP address there, and then type down the subnet mask there, and then type down the gateway information there, correct? DHCP is a method through which we can make this process dynamic. In this case, the router takes up the responsibility of assigning IP addresses to the end devices. So router becomes my DHCP server, which will assign the IP addresses, and these end devices are termed as clients. Between the server and client, there are four messages which are exchanged, and you can memorize these messages with the word DORA. The first message is discover message. Second message is offer. Third message is request. And the last and final message is acknowledgement. So let's understand how these four messages are exchanged between my server, which is a router or can also be a server, and the client device. First of all, my client is going to generate discover message, which is broadcasted to all the connected devices and is used for finding out where is my DHCP server located. Okay, this is basically done to find out where is the DHCP server. Now, the moment server receives a discover message, it realizes that some client is trying to get IP address. So it says, okay, I will offer you an IP address. So my server will reply back with an offer message. After that, client says that I accept your offer. I would like to request you to allot this IP address to me with the additional details like gateway and subnet mask. Server says, okay, I acknowledge your request. Here are the details and the IP is assigned to you. And after that, we can say my server will assign IP to the client PC. Using these four messages: discover, which is used for finding out the server; offer, which is an offer from the server to the client; request, where we are asking for the additional details; and acknowledgement, where we are acknowledging the request. Are we clear about these four messages and the process DHCP? Shall we look at the configs now? Great. So I'll share my packet tracer window again. And guys, the moment you are not able to see my screen, just follow a simple practice of dropping the call and joining it again, because that's a problem possibly from your end, as the other participants of the batch are able to see the screen. So quick suggestion is, whenever you face this problem, just drop the call and try to join again. Now what I will do is, on my packet tracer, I'm hoping now the screen is visible to all of us, right? Yeah. Okay. So now what I will do is, I will take again one router. I'll take one switch and I'll connect multiple end devices with it. Let's connect them all one by one. So first PC to switch, all the connections like this. And then I'll put the cable on my router also. I have taken the same router, 2811 router. I will always use the last router from the available options, 2811. Okay, so I suggest you guys also to go for that only. Now, after this, I would like to connect these end devices, which I have added here in my topology, in the network. Let's say 210.1.0/24. Okay. So tell me, what IP should I configure on the router's interface? Any IP basically from the range 210.1.0, correct? From the network 210.1.0. But a usual practice of networking industry is using the first IP on the router. Okay. So from the network 210.1.0, what do you think is the first usable IP? 210.1.1. So like I said, usually what we do in network industry, we use the first IP for the router. So what I am going to do is, I will configure 210.1.1 on my router's FA00 interface. Now you guys will tell me what commands should I type on the router to configure 210.1.1 on FA00. Write it together in a message and then send the message. All right, let's see. I'll go to the router 1. I'll get into the CLI. First, I will say no to this question. Then I will say enable to escalate my privileges. Then I'll type down configure terminal to get into the global configuration mode. Then we can set the host name as well. Host name, let's say R1. After that, I'll select the interface FA00 and type down IP space address space 210.1.1 space 255.255.255.0, and then finally no shutdown to bring up the interface. That's how we configure the interface, correct? Now let's look at how do we configure DHCP. For DHCP configuration, I will create a pool on my router, a pool of IP addresses. IP DHCP pool, and you have to give it some name. So I will give it the name, let's say PyNet. IP DHCP pool PyNet. Then you have to specify the network and the subnet mask for which you have created the pool. I have created this for which network, guys? Can I say 210.1.0? And if you remember, I told you network ID is used for representing the networks. So 210.1.0 is my network ID, correct? So network space 210.1.0 space the subnet mask 255.255.t55.0. Clear, guys? Okay, tell me along with IP address and subnet mask, what is the third information that we add on the PCs? In the previous example, we added a third information as well, gateway information, right? So we will add the gateway information also inside my DHCP pool by saying default hyphen address space 210.1.1. Okay, sorry, I guess default router. Yeah, sorry, my bad. The actual command is default hyphen router and 210.1.1, which is my IP of the router. And that's all. We are done. We can take the exit. I will write the commands here for you all. Enable configure terminal. Then we said host name R1. We went inside the interface FA0/0, assigned the IP address on it as 210.1.1, 255.255.255.0, and no shutdown to bring up the interface. Then took the exit and created IP DHCP pool called PyNet with a network defined as 210.1.0 and subnet mask as 255.255.255.0 and the gateway address as default hyphen router 210.1.1 and exit. These are the set of commands that I have added on the router. Now I'll show you the real magic. If I go to my PC, IP configuration, desktop IP configuration, and I click on this DHCP option, so it will automatically assign IP address, subnet mask, and gateway information. We can also add DNS information also through DHCP, but we will learn about it. I mean, DNS example or a practical is something we are yet to do. So that's why I didn't add it right now. But DNS IP address also can be added. Clear, guys? Similarly, I just simply have to go to the next PC, desktop IP, and click on DHCP, and dynamically IP, subnet mask, and gateway will be assigned to my PC. Next PC, desktop IP, DHCP, and you can see the IPs are getting assigned. So that's how we actually assign IPs when we talk about the actual networks or real networks. Clear? Let me know if there is any doubts or queries in this. Awesome. Now, I have shared one lab guide with you guys for configuring DHCP. If you will open this lab guide, it contains all the step-by-step information how you can practice DHCP in a packet tracer lab. So if you were not able to understand it through my explanation or demonstration, then you can follow the lab guide which I have pasted and can try out the example on your packet tracer. Clear, guys? Yes, Ankush, we are using a router as DHCP server. Is there any other questions related to DHCP, guys? Sham, to enable the interface names, go to Options, Preferences, and on the first page, you will see this option always show port labels. You have to make sure you check this box. When you check the box, you will start getting to see these port labels. Okay. Okay, we have two questions here. First question is from Saurabh. What if multiple networks are there? Like in the previous example, my router was connected to two different networks. So in that case, we can create two different DHCP pools. And the lab guide that I have shared, that contains an example with multiple networks only. So you guys can follow that. Second question we have is why we use excluded addresses. So guys, in DHCP, we can exclude IP addresses from the pool. Like right now, my pool contains the whole network 210.1.0, 255.255.255.0. That means all the IP addresses starting from 1.1 to 2. Sorry, 1.1 to 1.255 are part of my pool. But there is a possibility that I might want to, remove the first 20 IP addresses for some specific devices so that the remaining devices which are connected get IP from 1.1, 1.21 to 1.255. That's where we use excluded address range. Basically, when I will go to my router and I type down, if I type down IP DHCP excluded address and specify that I want to exclude address starting from 210.1.1 to 210.1. Let's say 25. Then from my pool, these IP addresses will be removed and the end devices will only get IP from 1.26 to 1.255. For example, now if on PC 12, I go and select DHCP, you can see it picked the for the devices on which you have already applied IP, like this is 1.2. If you click on DHCP option again, this time it will take it out of the excluded range. Can we configure DHCP and DHCP pool and switch? Rahim, we can do that if switch has IP configs. So as of now, we haven't discussed it. So right now, no. Okay, one more time. Go to options, preferences, and you have to check this option, always show port labels in logical workspace. Make sure it is checked and you will see the port labels. Okay. Is it possible for specific host only we need to apply exclude IP addresses? I didn't get your question, Sayed. Okay, I'll give you one example of how excluded ranges are used. Let's say my router is there. My router is connected to another switch, and with this switch, there are multiple servers which are connected. Okay. Server 1, server 2, server 3. Now, other than these servers, there are normal devices also which are connected. PC 14, PC 15. Okay. I want to make sure that on server 0, server 1, and server 2, I want to put a static IP so that it always stays the same. But on PC 14 and 15, I can use DHCP pool. Okay. So what I can do is I can put them all in the same network. On these three devices, I can put IP statically, but those IP addresses I will have to remove from the pool. I'll have to exclude them from the pool so that my router do not provide the same IP to PC 14 and 15. Make sense? Sayed, we cannot remove PCs from the range. We can only remove certain IP addresses from the DHCP pool so that DHCP do not provide those IP addresses to end devices. Like in my case, I have removed IPs starting from 1.1 to 1.225, right? So now, if let's say I will go and try using DHCP on any of the given PC, it will not get any IP starting from 1.1 to 1.25. It will get it only after 25. For different network, router can give same IP, right? No. For different networks, there will be different IP pools. And different network obviously means different IP networks. Like I told you, the example that I have shared, the lab guide that I have shared, if you will check that, I'll open it here also to explain you guys. It's for connecting two different networks also. Okay. So you will take one router, you will connect switches, PCs, assign IPs. Then on router, you will configure the host name, you will configure the IP addresses. So on one side, we have the network 192.168.1.0. On the other side, we have 192.168.2.0. So now for one side, you are creating a DHCP pool called A, and for the other side, you are creating a DHCP pool called B. Make sense? Then if you try assigning IP addresses, for the first network, you will get IP from the pool A. For the second, you will get IP from the pool B. Sure, the excluded address command is this IP DHCP excluded address. 210.1.1 means the starting IP. 210.1.25 means the last IP. So starting from 1.1 to 1.25, all the IPs are excluded. This command here. Any other doubts or queries? So we have some questions here. There is a command to refresh the IP assigned from the DHCP server. Yeah, the bindings can be cleared and can be removed also by using the command clear DHCP, clear IP DHCP binding. I guess packet tracer might not support that clear IP DHCP, yeah, binding. So it's not supported here on packet tracer. Also, this is not in the scope of CCNA. So no need to worry about that as of now. No, Michael, you can exclude IP addresses in the global config mode itself. As you can see, I didn't select any interface. I directly typed the command in the global config mode. Ankush, switches are layer 2 devices. Till the time there is no IP, the device cannot send packet from one side to the other. They are just helping us to forward the packet from PC to the router. So you cannot ping between switches or between PC and switch. Michael, then also the networks will be different, right? If let's say there are two pools, then both the pools will be for different networks. So depending upon your IP addresses, it will understand from which network you are trying to exclude IPs. Awesome, great. Cool, guys. I hope you enjoyed the class today. I have pasted the lab guide already. After the session wraps up, I'm going to share the notes as well that we have created. So that would be all for today. Thank you so much. I hope you learned something new today. I'll see you all tomorrow at the same time with some more topics and discussions. So take care. Bye bye. Enjoy your day.